Hey everyone, hope you're having a fabulous weekend today. Today we're going to discuss sections 1.6 and 1.7. Both deal with inequalities. We will start with section 1.6. So let me get my right pen here. And in spirit of Stanford's opening game tonight against San Jose State, we'll go with red. So section 1.6. That's on solving linear inequalities. They're very similar to solving linear equations. Just want to get x by itself. That's really it. So we will start with a very basic example. Let's say we have, try to find a good one here. Here we go. Number 1. Say you have 4x minus 8 is greater than 12. Alright? So again, your goal is to get x by itself. So what we do is we say 4x is greater than 20, x is greater than 5. And that's it. We're done with the problem. However, we do also want to graph your answer on a number line. So I put 0 in the middle, and put 5 obviously a little bit to the right of it. Let's say I put a open, or not an open circle, but unfilled circle is probably what we would say it. And I'm going to shade all the way to the right. And I wonder what happened to my line. Okay, that is so weird. It's okay. I'll draw it back. And let's just use a highlighter instead. That might be better. Okay. That's what we got. And again, it's got to be open. F5 and going to the right. We will now try another linear inequality. Number 2. Let's say you're asked to solve the following. Negative 4 is less than 6x minus 10, which is less than or equal to 14. Now this right here is actually called a compound inequality. And actually we call it the AND situation. The reason why is because 6x minus 10 is greater than negative 4, and 6x minus 10 is less than or equal to 14. So simultaneously, the expression 6x minus 10 has to be in between two values, greater than negative 4 and at the same time less than or equal to 14. One way you could solve it, instead of doing it separately, we could just do it all at one time. Let's add 10 to both, or to the left and right end. So add 10 everywhere. Divide everything by 6. And there you go. That's your answer. So we've isolated x in the middle. The graph on a number line, it would look like this. Here's 0, here's 1, here's 4. And just avoid the problem we had last time. Open at 1, close at 4, shaded in the middle. So therefore, x is sandwiched in between two numbers. And that's one way to help you remember the and inequalities, that x will always be sandwiched and, not sure if that kind of rhymes, maybe that helps, I don't know. But x is always in between two numbers for the and situation. For number 3, so you probably guessed, we're now going to look at the or situation. Let's say I have the following. Negative 3x plus 5 is less than or equal to 11. Or negative 5x minus 7 is greater than or equal to 23. So let's see what happens here. Now in this case, you're going to have to do separately. So negative 3x less than or equal to 6. X is greater than or equal to negative 2. Notice how this switches, right? Very, very important. It might be a review from Algebra 1 a while ago. Switches when multiplying or dividing by a negative number. Okay? For the other one, negative 5x greater than or equal to 30. X is less than or equal to negative 6. So now we graph on number line. And by the way, we say our answer is that or that. Because no way it could be greater than negative 2 and less than negative 6 at the same time. So it's one or the other. So you got 0, negative 2, negative 6. Both are going to be filled in circles because they both equal negative 2 and negative 6. But notice now they go in opposite directions. We're going to the right of negative 2 and to the left of negative 6. So this is called the OR situation. Because x is one or the other. Either it's less than negative 6 or negative 2. It can't simultaneously be both those things. If you think about it, it kind of looks like two oars in a rowboat. Not sure if that helps, but that's the OR situation. That pretty much sums up 1.6. So now we can move on to 1.7. 1.7 deals with absolute value equations and inequalities. So section 1.7. So we'll do some examples here. Then I think we should be good for the weekend. Number 1. Very simple. Absolute of x minus 5 equals 7. Now if you think about it, what is absolute value? Absolute value is kind of thinking about how far something is from 0 on a number line. So absolute value distance from 0 on a number line. So for example, the absolute value of negative 4 is 4, because negative 4 is 4 away from 0. Or the absolute value of 4 is also 4, because 4 is also 4 away from 0. So that's basically one way to look at an absolute value. So in this case, the problem that we actually want to solve, remember we're trying to solve for x. X minus 5 could hold two values. It could be 7 or negative 7. And we want to know what values of x will make that happen. What values of x can make this 7? What value of x can make x minus 5 negative 7? So 12 or negative 2. So both those answers work. So you will expect two answers for these. And again, 12 is 7 away from 5. Negative 2 is 7 away from 5 on the number line. Let's step this up now. Let's say we do the absolute value of 2x plus 12 equals 4x. Now this is a little bit harder to visualize because of course you know x minus 5 has to equal 7 or negative 7, and you want to be 7 away from 5 on the number line. A little tougher here. But using the same algebraic technique, solve it like the way it looks if the absolute value never existed, and then set it equal to its negative counterpart, which would be negative 4x. 2x equals 12, x equals 6. Negative 6x equals 12, x equals negative 2. So we get two answers. However, before I circle each one to say, okay, that's the answer, you must check. 2 times 6 plus 12, does that equal 4 times 6? It sure does, because that's why 12 plus 12 equals 24. 24 equals 24. It's all good. But what if we do this? For negative 2, we're going to have a problem. What's absolute value of negative 8? Remember, absolute value must always come out as being positive. 8 doesn't equal negative 8. So we say no way for that one. Yes way for 6 is the answer. So do check your work for the absolute value. Very, very important. We'll try one more. We'll try an absolute value inequality, and then I promise we're done for the afternoon or weekend, whatever you want to call it. Let's say you're asked to solve this. So 4x plus 5 has to be greater than 13. Like for example, 4x plus 5 could hold the value of 20. 4x plus 5 could hold, 4x plus 15 could hold the value of 20. 4x, okay, I am just losing my mind. I meant to say 4x plus 5. So everything I said the last 30 seconds, get that out of your head. 4x plus 5 could hold the value of 20. 4x plus 5 could hold the value of 100, and so forth. Or 4x plus 5 could be less than negative 13. So 4x plus 5 could hold the value of negative 20, because when you take absolute value it works. Or 4x plus 5 could hold the value of negative 100, because after you take the absolute value, it will be okay. So 4x is greater than 8, x is greater than 2, 4x is less than negative 18, x is less than negative 18 fourths, which is going to be negative 4.5. So now we graph it, and if you think about it, this is the OR situation, because something is greater than 2 or something is less than negative 4.5. You can't have both. So here's negative 4.5. Here's just a little more scale. Great. Here we go. 2. And non-inclusive, so we put non-filled in circles to the left, to the right. So whenever you have the greater absolute value inequality, that's going to result in the OR compound inequality. So greater OR. So greater for absolute value results in OR. And if you were to do less than for absolute value, it would lead to AND. Kind of rhymes, less than, and, greater, or. So if you see absolute value greater than something, it's going to be OR inequality, less than, and. You'll have some opportunities to work these out when we meet again during block 1 next week. And this time I am serious. We are done. No more being kidding. So thanks for stopping by, and hope everyone has a fabulous weekend. All right, bye.